This is the first study that calculates regionalized greenhouse gas emissions in Europe associated with household consumption. We further studied the potential driving factors behind those emissions. You can find the complete regionalized accounts in the supplementary files and also emissions by consumption domains, such as emissions from food or mobility.
We combined regionalized consumer expenditure data with multi-regional input-output framework to link local consumption to its global impact using a life cycle perspective. We calculated the total household carbon footprint for 177 regions in 27 EU countries. This map displays the total household carbon footprint as a function of a region's population and consumption. Per capita emissions appeared normally distributed with mean and median of 11 tons CO2 equivalent and standard deviation of 3 tons CO2 equivalent. The top 10% of the population with highest household emissions have footprints between 22 and 16 tons CO2 equivalents per capita. This top decile emits about 15% of EU's household emissions. For comparison, the bottom decile emits between 5 and 7 tons CO2 equivalents per capita, or about 5% of EU household emissions. Countries show different levels of diversity once you zoom into them. And while the German national average is higher than those of Spain and Italy, there are Spanish and Italian regions that surpass some German regions in terms of carbon footprint per capita. Italy, Spain, Greece, and the UK stand out with the highest footprint differences across their regions, while other countries such as Denmark and Czech Republic appear much more spatially uniform. We also tested if factors that were previously hypothesized to influence footprints in the literature explained the observed footprint differences across and within countries. Socioeconomic factors such as income, household size, education, dwelling size, and basic need consumption generally explain between 15 and 70% of emission variation across consumption domains. Income has the highest explanatory power alone, explaining 30% of the total household carbon footprint. There are higher subnational differences in emissions associated with income-elastic domains such as clothing, services, and manufactured products, especially in countries with higher income inequalities. Our analysis suggests that clothing emissions will become increasingly important, even though clothing currently contributes to only 4% of EU household emissions. Temperature differences and carbon intensity of the electricity mix together explain close to 60% of the regional shelter-related emissions. Other factors, such as household size, also appear important, where an increase of household size leads to a drop of emissions from electricity, housing fuels, and waste treatment. Impacts from housing dominate Finland, Poland, and Czech Republic. Transport brings about 30% of EU household emissions, with varying importance across regions. Income and urban-rural typology appears to be most significant driving forces behind these emissions. Impacts from transport dominate countries such as Luxembourg, Greece, and Denmark. Food emissions are rather income inelastic, and they contribute to a share between 11 and 32% of a region's total. The largest inter-regional differences occur in Spain and Greece, mostly due to varying consumption of animal products and processed food.
This study makes an important contribution by providing regions and local governments with emission information that they could use when they set up their climate priorities.